Hey fellow problem solvers, Colfax Math here. This is going to be a video in a playlist called IB Math SL AA. So this is going to be chapter 12 in the Oxford Analysis and Approaches math book for IB Math. And what we're going to do today is we're going to go over what radians are. So we've been talking about degrees all along. If I draw my unit circle, it is called a unit circle because the radius is 1 unit long. All the way around a full revolution is 360 degrees. That's a great number because it's divisible by 90, by 180, by 45, by 30, by 60, which also gives us our two triangles we need to know, which is a 30, 60, 90 right triangle and our isosceles right triangle. So these are two triangles you just have to have memorized, and the ratios of sides will always be the same. In a 45, 45, 90 triangle, if this were 1, this would also be 1. If the angles are congruent, the sides opposite would have to be congruent. 1 squared plus 1 squared is 2. Square root of both sides, this is root 2. In a 30, 60, 90 triangle, if the ratio opposite the 30 is 1, the ratio opposite the 60 is root 3. And then I use the Pythagorean theorem, root 3 squared plus 1 squared equals 4. Square root of 4 is 2. Well, plus or minus 2, but I discard the negative. So we're going to use these two triangles and this circle, and we're going to look at radian measure defining trig functions. So all the way around again, it's 360. I think it's probably based on the sun, and it's how many days in the year, and then rounded down to a number that's easily divisible. So if that's 360, this is 180, this is 90, this is 270. Then I could split those again, and I'm going to split those into halves. So half of 90 is 45, and that's where this one's going to come into play. This one's also a 45, but it's a 45 beyond 90, so 135. This one's 45 beyond 180, 225. 45 beyond 270 to give me 315. And those are all going to be 45 reference angles, because when I draw my triangles in my unit circle, I go straight down to the x-axis. We're going to look at all these in radians after we're done looking at these two triangles. Now I'm going to split it with a 60 from this triangle. So 60 would be right here. 60 degrees is 1/3 of the way to 180. And then right here, a 60 reference down here would be 2/3 of the way to 180, or 120 degrees. Then there's going to be a 60 here, back to the x-axis at 240 degrees. And a 60 down here at 330 degrees. Getting a little crowded here. And then back to 360. Lastly, we're going to have our 30-degree angles here. Kind of running out of colors here. My 30 will be here, related to this triangle. There's my 30 degree. 30, 60, 90, 120. Here's my 150. Right here is 30 beyond there, 210. 210 plus 30 plus 30 plus 30 plus 30, my 330-degree angle. So those are all my exact value angles, and they're related to these two triangles. Remember, this is the unit circle where the radius is equal to 1. So the circumference of that circle is equal to 2 pi r. However, r is 1. The radius is equal to 1. So I just plug a 1 in there, and I can see all the way around that circle is 2 pi. Now that I know all the way around that circle is 2 pi, rather than talk about them in degrees, I could talk about them in radians. So I could either travel 360 degrees to get here, or I could travel a circumference of 2 pi to get here. So the equivalent of 360 is 2 pi. So that means half a circle would be pi. Half of pi right here would be pi over 2. right? I got 1/2, 1, 1.5, 2. 1.5 would be 3 pi over 2. Again, it's a unit circle. Radius is 1. All the way around is 2 pi or 360. There are two different types of units. One is called degrees. You always have to have the units attached to it. The other one is radians, and you don't have to have the units attached because radians are, in fact, unitless. So let me just go over that for 1 second. Circumference is equal to diameter times pi. 2 radius, same thing as diameter. If circumference were in inches, diameter in inches, I would divide both sides by diameter in inches. These would cancel, and I could see pi is a ratio of circumference to diameter. My inches would cancel, and pi is unitless, therefore radians are unitless. All right, let me go over one more piece here. Let's look at the red and the green and the black values. So if all the way around is 2 pi, I split this into pi, cut that in half. Now to get my 45s right here, I'm going to cut that half in half. So pi over 2, half of that, pi over 4. So that means I'm counting in quarters now. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. So I could count it in quarters, remembering all the way around is 2. Now let's split it into our 60s in radians. So our 60s in radians, 60 is 1/3 of 180. So this is going to be pi over 3, 1/3, 2/3, 3/3, 4/3, 5/3, a little out of room here, 5/3, 6/3, right here, right? So again, by thirds, 1, 2, 3, 4, 5, 6. Lastly, I'm going to do my 30s now. And my 30s are 1/6 of the way to 180, right? 30 is 1/6 of 180. So this is 1/6. This is 2/6, 3/6, 4/6, 5/6, 7/6. No, I'm sorry, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6. So there's our unit circle in degrees and radians. And then the last piece, I probably should do on another video, is to use our trig functions on our triangle to find exact values. But if I had, say, the sine of 30, the sine of 30 would be this triangle here. Sine is a ratio of opposite over hypotenuse, so it would be 1/2. Sine of 150 is this triangle over here. It is still at 30 reference. The opposite is still positive. It would still be 1/2. Sine of 210, now it's down here in the third quadrant where my opposite is -1. Hypotenuse is always positive 2. So sine of 210 would be -1/2. And right here, the opposite's down. So sine of 330, sine of 11 pi over 6, same thing, would be the -1/2. Quick introduction to radians, the unit circle, and how it's all divided up so you could use these two different triangles for exact value problems.